Supposing we have an equation like the one here in the upper left, 2x squared minus 4x minus 3 equals 0. And we want to get the solutions for that. We want to get the x-intercepts. Now we could draw a couple of brackets and see if we could factor it. We could complete the square if we wanted to find out certain key features of what the graph would look like. But the simplest way of dealing with a quadratic is using the quadratic formula, which is what we have over here on the right-hand side. That's negative b plus or minus the square root of b squared minus 4ac, the whole business over 2a. And the way that we apply that is, well, any quadratic equation, or quadratic equations in general, can be represented thus. ax squared plus bx plus c equals 0. That is to say, something x squared plus something x plus some other number equals 0. In math, we generally represent plain old numbers by letters from the beginning of the alphabet, like A, B, and C, and variables by letters from the end of the alphabet, like X, Y, and Z. So this is the kind of the model of a quadratic equation, and in this case, in the A place, we have an a2, in the B place, we have a negative 4, and in the C place, we have a negative 3. So if we were to take the numbers which correspond to the A, B, and C letters and plug them into our equation, we would get, well, we get negative 4. We want to keep the sign that appears in the actual equation, plus or minus the square root of negative 4 squared minus 4 times the A is a 2, and the C is a negative 3. And this whole business over 2 times A, which is 2. So minus 4 is positive 4, plus or minus, and under the square root bracket we have negative 4 squared, which turns out to be positive 16. Then 4 times 2 is 8, times 3 is 24, and negative times a negative is a positive. So that's plus 24, the whole business over 2 times 2, which is 4. So now we've got 4 plus or minus the square root of 16 and 24 will give us a 40. All this over 4. Then 4 plus the square root of 40 can be simplified into, well, 40 is actually 4 times 10, which is equal to 2 squared times 10. So we can take out the 2 squared. 4 plus 2 times the square root of 10. That whole business over 4. Once we've got to this point, you've got 4 over 4 plus or minus 2 times the square root of 10 over 4. 4 over 4 is just 1. That's plus or minus. We can factor a 2 out of the numerator and the denominator. So 1 plus or minus the square root of 10 over 2. And there's our answer. Now, applying the quadratic formula may seem a great deal of trouble, but once you become practiced with it, you'll find that it really is a very fast way of getting your answers. And you'll find that you're plugging this formula into your calculator, hitting enter and getting your answer before you know it. The hardest part about the quadratic formula is probably remembering how it goes. And you can memorize this by brute force, but the most interesting way of learning it is to derive it. If we took our typical quadratic equation, ax squared plus bx plus c equals 0, and we solved it by completing the square, we would end up with the quadratic formula. Here's how it goes. First, we move everything which doesn't have an x in it to the right-hand side of the equation. So minus c, and now we have ax squared plus bx is equal to negative c. Then we want to be sure that it's just a bare x squared. We want to remove the coefficient from the x squared. So we're going to divide everything in the entire equation by that a. These cancel out. Now we've got x squared plus b over ax is equal to negative c over a. Next, we're going to take the linear coefficient, the coefficient on the x. We're going to halve it, square it, and add it to both sides. So to halve it, we multiply it by 1/2, so that's b over a times 1/2 equals b over 2a. And we're going to square it. So now we've got x squared plus b over ax plus b over 2a squared is equal to negative c over a plus b over 2a squared. To recap, we moved the c over to the left-hand side of the equation. We divided everything by a to clear the coefficient from the x squared. Then we took the linear coefficient, we halved it, we squared it, and we added it to both sides, which is why we have a b over 2a squared on both sides of the equation. Now, on the left-hand side, we're going to take the squared elements and bring them down without their squares. So it'll be x plus b over 2a, this whole business squared. And this is going to be equal to minus c over a plus, let's square this. Now, b over 2a squared, that's the same as b squared over 2a squared, which is the same as b squared over 4a squared. So we've got negative c over a plus b squared over 4a squared. And what we'd like to do is combine the two fractions on this side of the equation. So we're going to have to take our negative c over a, and we're going to have to modify it so it too will have a 4a squared in the denominator. The way we'll do that is we'll multiply the denominator by 4a, and 4a times a gives us 4a squared. And to make this proceeding legitimate, we'll multiply the numerator by the same. So it really counts as multiplying our negative c over a by 1. Now we've got negative c times 4a is minus 4ac in the numerator, and in the denominator we have 4a squared. So we've taken our negative c over a and we've modified it into this. Now we can add it. So we now have x plus b over 2a squared is equal to minus 4ac over 4a squared plus b squared over 4a squared. And when we combine them together, we're going to get b squared minus 4ac, the whole business over 4a squared. Now, our next move is to try and get the x all by itself. So the first thing to do is to clear this side of the equation of the squaring. So let's take the square root of the whole side and the square root of this whole side. And the square root of this squared is x plus b over 2a is equal to now plus or minus, because we don't know whether this is a positive or a negative outcome that's been squared under here. The x could be either, and the outcome of x plus b over 2a could be a positive or a negative number. This is going to be equal to the square root of this whole business. Now we can express that as the square root of b squared minus 4ac over the square root of 4a squared. since taking the square root of the top and the bottom of a fraction is taking the square root of the top and taking the square root of the bottom. Now we've got on this side x plus b over 2a is equal to plus or minus. There's really nothing we can do with this, so we're going to leave it in its bracket. B squared minus 4ac over, now the square root of 4a squared. Both 4 and a squared are perfect squares, so we can reduce that to 2a. And now we can subtract a b over 2a, b over 2a from both sides of the equation. On this side, these cancel out, and now we've got an x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, and we can combine those two since they have a common denominator. So now we've got x is equal to negative b plus or minus the square root of b squared minus 4ac, the whole business over 2a. And that is the quadratic formula fully derived. The reason it's worth your while to learn how to do this is that it's more interesting, less time consuming, and a bit more fun to learn how to derive the quadratic equation from ax squared plus bx plus c than it is to just memorize it in this form by brute force. Also, if you learn to do it with all the steps, it's sort of like in music when you learn how to play scales. You know where everything is, so when you actually got a piece you've got to perform, your fingers automatically go where they need to. So if you can take ax squared plus bx plus c and take it through all its steps to get to the quadratic formula, you'll not only have perfectly memorized the quadratic formula and made it your own forever, but when it comes time to completing the square, you're going to know automatically how to do it. You'll just do it at lightning speed because you'll have a real expert knowledge of how it works in absolutely every case in the most general form. So a specific case, no problem at all.